Hey guys, this is Sijia. I'm very glad to show you the development process of group RedBack. I will briefly introduce our project structure. The development of our group project mainly consists of three parts: web drawing board, RS2, and now robot. The purpose of the drawing board is to capture the user stroke and recognize the user handwriting through the user writing on the drawing board and send the handwriting information to RS2 nodes. The purpose of RS2 is to compile the underlying logic of the robot and manage the control various function of the robot. The purpose of now robot is to use the handwriting information transmitted from the drawing board to learn from the algorithm, so that the robot itself can follow the user to draw the same handwriting. We have successfully realized the construction of a web drawing board, the capture of user handwriting information, RS2 robot-shaped learning programming, communication function between drawing board and RS2, as well as achievement of robot movement. In the next sprint, we will add the communication source between RS2 and the now robot to let the robot stimulate the user's stroke path by moving the robot arm. Now, let's welcome Ming to introduce the drawing board in detail.
Now I will be introducing our drawing board. As you can see, this drawing board operates on a Docker container. Later in the project, we will also utilize it to deploy our drawing board. At present, our drawing board only has the most fundamental functionalities. The area highlighted in light gray background represent the canvas. In addition, there are two essential buttons, one for transmitting the shape to backend for processing, and the other to clear the canvas. We've also incorporated an input box that communicates to the nail board the specific characters or word that the user wants to practice. Let's engage in a small demonstration by drawing a character on the canvas, for example, A. Now, let's navigate to our backend. As you can observe, I'm operating three nodes. The primary node is dedicated to interpreting the user input. The secondary node is equipped with our learning algorithm. The final node is tasked to transmitting the computed shape that the nail board will replicate on a physical board. For the sake of this demonstration, I'll visualize the shape with the help of matplotlib. Now, by clicking the Get Shape button, the drawing is sent to the backend, processed by this node before finally being transmitted to the nail boards. The plot shown here indicates the trajectory that we aim for our nail board to replicate. Now I would like to invite Yuhan to the stage of demonstrating the practical usage.
Hi guys, I'm Yuhan. Please let me show you an arm movement of a Now robot in choreography through Nowken SDK coding. First of all, you can see that our robot model is Now. And after executing the code, you can see that the robot can move its arms. The movement trajectory of the arm movement is pre-written. Okay, now the robot has completed one arm movement and is back in the upright position. In the next sprint, we will make the robot implement arm movement according to the coordinates of the user strokes transmitted from ROS2 through a socket. Thank you.